In this video, we will see what is graph, what are the ways to represent the graph, and what are the advantages and disadvantages of those representation. Graph is a collection of vertices and edges. It means G is equal to VE. V means set of vertices and E means set of edges. These are the examples of the graph. If you observe that A, B, C, D, E, these are called as the vertices, and the link which are connecting these two vertices is called as the edges. So I will say that graph is a collection of vertices and edges. Where I can use this data structure to represent the social networks, roadmaps, communication network. In such a cases, we can use this data structure. There are two ways to represent the graph. First one is the adjacency matrix and second one is the adjacency list. We will see both these methods one by one, as well as we will see what are the advantages and disadvantages of those methods. Let's start with the first graph representation technique, that is the adjacency matrix. Within this, we will declare the two-dimensional array. The size of that array will be depend upon how many vertices are there in the graph. In this example, this graph contains the 5 vertices. So we have to declare the 5 by 5 matrix. It means it contains the 5 columns and 5 rows to represent this graph. So rows index always starts from the 0. So it will go from the 0 to 4. Same for the column as well. The index will go from the 0 to 4. This 0th column represents the actually data of the vertex A. Same way for the B, C, D and E. Same thing will be applicable for the row as well. This 0th row index will be represents the data which is related to the vertex A. Same thing for the B, C, D and E. Now this is the actual data will be present in your matrix. It contains only zeros and 1. But when to put the 1 and when I can put the 0. If there is an edge exists between I and J, then I will put the 1 value. Otherwise, I will put the 0. Consider I just want to make entries for this, or I want to store the data related to the vertex A. Then what I will check, is there edge between A and vertex A? It means it contains self loop. Then I will put 1, otherwise 0. Right now there is a no, you can say self loop. So I will put 0 at this location. After that, I will check, is there edge between A and B? Right now there is edge from A and B. So we will put the 1 here. Same for the C as well, but there is a no edge from the A to D and E as well. So entry will be 0 in this case. Same thing we can do for the B as well. From the B, there is a edge to A, C and D. So entries for the A, C and D will be 1. Otherwise, remaining entries will be 0 for the B. So same case will be applicable for the C, D and E. Like that, you can do the entries in your matrix which will represent this graph. Now if you observe that the diagonal entries are 0 because there is no any self loop present into this graph. Observe that upper side of this matrix is a mirror of the lower side as it is an undirected graph. Next, we will see one more example of the adjacency matrix. In this case, we will take directed graph. It means each edge has a direction. Here in this case, I can go from A to B, but I cannot go from B to A. So that is called as a directed graph. Same way, we have to use the two-dimensional matrix to represent the directed graph. Here as well, size of the array will be depend upon how many vertices are there. Here it contains 5 vertices, so it will be 5 by 5 matrix. Now here I will check if there is an edge between A and B. No, there is no edge, so we will put the 0. And if you observe that there is an edge from A to B, C and D. So we will make those entry as a 1, B, C and D. Entry for the E will be 0 as there is no edge from A to E. Now same thing we will see for the B. Now if you observe that from the B you cannot go to the A. So entry will be 0 here in this case. After that you cannot go to the C, D, but you can go only to the E from the B. So for the B row, the the entry for all the vertices will be 0 and only for the E vertices it will be 1. So like that you can do the entries for C, D and E. So this is a simple way to represent the graph with the help of adjacency matrix. Next we will see what are the advantages of this representation. First advantage is it is easy to implement and understand. Another thing is only one lookup I will get to know that whether there is an edge between these two vertices or not. Consider I want to check out whether there is an edge present between A and D. I will go into the A row and I will check the D column. Entry is a 0, it means there is a no edge between A and D. Same thing, suppose I just want to check is there edge between A and C. So I will go for this row and check the entry in for the C column. So entry is a 1, so I will say that there is a edge between A and C. So you can say quickly I will get to know that whether there is a edge between two vertices or not. Next advantage is it is used for the dense graph. Dense graph means it contains the more edges. If the graph contains less number of edges, then most of the entries will be 0. And if graph contains more edges, then most of the entries will be 1. So when this representation will be, you can say useful when there is a dense graph which contains more edges. What are the disadvantages of adjacency matrix? First disadvantage is related to the memory. Consider I want to represent this graph with the help of adjacency matrix. Then you have to declare the array which contains 5 rows and 5 columns. It means you are allocating the memory for 25 elements. Second disadvantage is it is not useful for the sparse graph. Sparse graph means it contains the less number of edges. Third disadvantage is it is difficult to iterate over the all neighbors efficiently as we are storing both the information, means the vertex is connected to the particular vertices or not. Both information is stored in this row. So it is a little bit difficult to iterate through all the neighbors of the A. Fourth disadvantage is adding and deleting vertices can be costly. It means suppose I want to add one more vertices here, then you have to add one more row and one more column in this case. Second representation technique is an adjacency list. In this case, we are using the linked list to represent the graph. Suppose I want to represent this graph with the help of adjacency list. So I will pick up the one vertex from this graph. For this, we will create a one node which has a 3 parts. Data part will contain the vertex information of the vertex A. After that, this next part contains the information related to the adjacent node of the vertex A. A is connected to the B, so we will create a node which contains the B value, and in the next part they will link the next another vertex, that is a C, and after that next part of the C contains null as the A is connected to the only 2 vertices. Now there is a one more vertex in the graph, so we will say that after A there is a one more vertex into the graph, the vertex B. Now for the B, I will just store the what are the elements are adjacent to the B. B is connected to the only vertex A, so we will add one node here A, and next part of the A contains null. After storing the information of the B, there again one more element into the graph, so we will store the information related to the another vertex C. For the C, which are the adjacent element of the C? C is adjacent to the A, E and D as well. So we will store information like C is connected to the A. After that it is also connected to the D. Also it is connected to the E. So we have finished with the elements to which the C is connected. So at the end we will put the N here. Now graph contains one more vertex, so we will store the information of the vertex D. D is connected to the C as well as E. Now E contains the null value. After that we will store the information related to the vertex E. E is connected to the C and D. Here we can write down D first, and after that we can write down C as well. Order is not matter here. Now there is no more vertex remain from this graph, so the E contains the null value into this part. Like that you can represent the graph with the help of adjacency list. It is a useful for the sparse graph. It means the graph which contains the less number of edges. Easy to iterate through the neighbors. Means suppose I just want to check out to which vertices C's are connected. So I will go here and I will check out what elements are present into this horizontal list. Through that I will easily get to know that which are neighboring vertices of the C, as adjacency list only stores the information of the adjacent element. It is not storing the information related to which vertex C is not connected. But in case of the matrix, we are storing both the information. Now next advantage is simple to add and remove the edges as well as vertices. Consider I want to add one more vertices, so I will just create one more node here. Consider I want to add one more edge for the D, then he can easily add one more node here as well. So it is easy to add and delete the vertices as well as edges from the adjacency list. Now next one is, it is a good for to traverse the graph with the help of DFS and BFS. These are the two techniques to traverse the graph. DFS means depth first search and BFS means breadth first search. What are the disadvantages of the adjacency list? It is a slightly complex to implement and less efficient for the dense graph. It means graph has a more number of edges. Consider I want to check whether C is connected to the E or not. So I will check the adjacency list of this vertex C. In this case, C is present at the end, but you cannot directly jump to this node as only sequential access is possible. So I will first visit this node, then this node, and at the end I will get to know that C is connected to the E as well. And what is the worst case complexity for this? It will be V. V means number of vertices which are present in your graph. I hope you understand graph representation technique. Thank you.